Today, on how it's made. Pipes. Rock climbing gear. Leather bike saddles. And luxury sports cars. When Christopher Columbus discovered the Americas, he also discovered the tobacco pipe. The pipe was an important part of native culture, to be shared during times of negotiation and celebration. Columbus and other explorers brought the concept home, and the rest is history. Since the 19th century, pipes have been made from briar, a hard, fire-resistant wood from the root of a Mediterranean heather shrub. After the briar has cured for several months, the pipe maker saws it into a rough pipe shape. Using a lathe and chisel, he rounds the larger block to approximate the shape of the pipe bowl. He bores through the center to carve out the tobacco chamber. Then he slims down the stem, marking the center for drilling later. The pipe maker finalizes the shape by hand. He now sands both the inside of the tobacco chamber and the outside of the pipe bowl. Next, the pipe's mouthpiece takes shape. The pipe maker pierces a piece of hardened rubber called vulcanite to establish the center and then drills a channel through it. Using a grindstone, he sculpts one end, taking it from round to oval, a shape that fits more comfortably between the lips. He checks his work with a sizing template, then shaves the exterior of the mouthpiece, reducing it considerably. He shapes the other end to form the tenon, which fits into the pipe stem. He polishes the tenon with a special compound. The smoother surface makes this part easier to join to the pipe stem. Using a series of sanding discs with progressively finer grit, he gives the exterior of the mouthpiece a sleek finish. Then he steadies it in a clamp and widens the hole in the center of the mouthpiece to broaden it into a funnel-shaped cavity. Attention now turns to the seam between the rubber and wood parts. He sands it to make them perfectly flush. Hand filing removes blemishes and adjusts the thickness for a more comfortable bite. The thickness can be customized for individual preferences. He drills a tiny hole into the top of the mouthpiece. Then dips a thin plastic rod in glue and inserts it in the hole. He sands it down, leaving a white spot, a marker that indicates the mouthpiece is right side up. For bent or curved pipes, the mouthpieces are heated in an oven at 160 degrees Celsius. This makes the vulcanite flexible enough to be shaped by hand. The pipe maker bends the mouthpiece to the desired shape, and a quick cool down in water re-hardens the vulcanite, fixing its curve. Next, he buffs the wooden part of the pipe. This removes fine scratches and brings out the wood grain. It also gives the wood a glossy finish. But for a different finish, a craftsman sandblasts the briar wood, giving it a rippled texture. He stains it darker with an alcohol-based dye, working the stain into every crevice. And now, for a neat trick, he sets it on fire, and the alcohol burns off to set the stain. The pipe doesn't go up in flames, proving it's truly fire-resistant. He burns up to 10 layers of stain into the pipe, depending on the effect he's trying to achieve. Finally, he stamps the company name and other information into the pipe. After a final quality inspection, this handcrafted Breyer pipe is on its way to making a statement at the country club. Rock climbing is no pastime for the faint-hearted. Scaling natural rock formations or man-made rock walls requires a certain fearlessness, along with good physical conditioning, balance, agility, and you must be well trained in climbing techniques and use specialized equipment. Climbers usually work in pairs, using a system of ropes and other devices to catch them if they fall. A key piece of gear is the spring-loaded camming device. The climber pulls the trigger to contract the cams and position it in a crack, then releases the trigger to expand the cams, which securely grip the rock on either side, then attaches a rope through a device called a carabiner. Climbers typically carry several types and sizes of cams, carabiners, and other devices. The equipment must be as lightweight as possible, yet at the same time strong enough to save a falling climber. Which is why this manufacturer uses aircraft-grade aluminum. To make carabiners, automated saws cut aluminum bars into pieces the required length. Then a bending machine forces each piece around a form in the basic shape of the carabiner. Carabiners come in various sizes and shapes. Workers simply mount the appropriate form on the machine. Next, they place the roughly formed carabiner onto a hot die. Another die slams down on it with up to 800 tons of force, forging the final shape. Then, the most critical part of the manufacturing process, a multi-phase heat treatment to harden and strengthen the aluminum. Next, they use a clipping press to slice off excess metal along the perimeter. This leaves rough edges, which they now smooth out using an abrasion process. The carabiners go into a vibrating tub where they rub against porcelain chips for the next 20 hours. Next, workers drill holes for the rivets on which the spring-loaded opening mechanism will hinge. That mechanism, called the gate, has channels which align with these holes. Assemblers slot a spring and spring pusher into the gate, then insert the rivets through the aligned holes and channels. A riveting machine locks each rivet in place by rounding and widening the head. Then they adjust the carabiner's frame until the alignment is perfect. After a thorough inspection, a laser etching machine inscribes product information and a unique serial number. Random samples undergo strength and other quality control tests. Elsewhere in the factory, camming device production is underway. Computer-guided equipment machines the same aluminum alloy to a preliminary shape, saws off slices, then machines each slice to the final shape of a cam. An assembler attaches a wire to each cam, then takes 4 cams and joins their wires to the trigger wires with a metal crimp. The cams by this point are different colors. That's because they've undergone chemical treatment to make them corrosion resistant. This process can in fact produce various colors, so at the same time, the company can color code the different models. As assembly continues, they thread the cams onto an axle-like component called the spindle, positioning a spring in between each cam. The springs provide the resistance required to expand and retract the device. A cone-shaped washer on each end of the spindle holds everything together. This time, the riveting machine locks in the components by flattening and widening the end of the spindle to fill the hole in the washer. With that, the camming device is finished. This is how camming devices, carabiners, and other climbing gear all work together to catch climbers who lose their foothold. Not only do they keep climbers safe, they also protect nature because they attach to the rock face without damaging it in any way. Leather bike saddles feature a leather top suspended on a metal frame. With time and use, the leather molds itself to perfectly suit the rider's anatomy and their cycling style. And just like a pair of leather shoes, the saddle becomes very comfortable. Leather bike saddles look almost the same as they did 100 years ago. They are still made by hand and by some machinery that is sometimes over 60 years old. Saddles are made exclusively of metal and leather, traditional materials that retain the style and quality of the early days. The first step is making the steel wire springs for saddles that have a suspension. The machine coils and cuts the wire to the proper length. Liquid lubricant keeps everything running smoothly. Depending on the saddle's model, some springs are then chromed. This machine folds and curls steel or titanium wire to form brackets. It's adjustable, so it can make brackets of different sizes and shapes depending on the model being produced. A technician assembles the springs and brackets to form the saddle's frame. He attaches the clamp so that the saddle can be attached to the bicycle's seat post. Saddles come in different sizes and shapes, with or without suspension springs, to accommodate various riding styles: racing, mountain biking, or city commuting. Now for the saddle's leather top. Using a hydraulic clicking press, the worker cuts the leather with a sharp blade. The blade cuts ventilation holes at the same time. Tanneries provide leather in any color required by the factory. After the tops are cut, they soak in tepid water for 20 minutes to an hour until the leather is completely saturated. The wet leather top then goes to a press, which applies 2,000 pounds of pressure per square inch. Using a leather cushion, the technician pads the leather piece to help reinforce the shape, especially in the narrow front end. Because the top is wet, it retains the shape and does not bounce back. They carefully sand the leather to get a smooth edge. The tops now go into the oven for 3 hours at a maximum temperature of 55 degrees Celsius. Now they're ready for the finishing process. A worker rivets a nameplate to the rear of the saddle. Then stamps a trademark on each side. Each saddle model has its own trademark. They attach the nose to the front of the saddle using solid copper rivets. They hammer each one down carefully to follow the contours of the leather without scratching it. This machine now rivets the frame to the back of the saddle. They insert a tension pin between the frame and the nose. This pin will allow the rider to adjust his saddle if the leather starts sagging after a few years. It takes about 3 days to make a leather bike saddle. And with careful care, it can be used for years to come. Luxury sports cars are coveted by people around the world, and with good reason. The extraordinary skills and materials that go into making them were developed from a long racing heritage. Each one of these automobiles is born from expert craftsmanship and a passion for racing. Underneath the beautiful exterior of these cars lie a chassis and powertrain capable of delivering remarkable performance. The aluminum frame is engineered to be lightweight yet rigid and provides crumple zones that can evenly distribute force in the event of an impact. It takes highly skilled technicians to perform these complex welds. On the factory floor, robots transport the body panels that will later be fitted onto the chassis. Once the frame is completed, technicians use a pneumatic hoist to position and attach exterior panels and doors. Door panel cutouts reduce the car's weight while retaining a high degree of structural integrity. The elongated cutouts on this model will house its stylized headlights. Next, they coat the car in a compound which fluoresces under a special lighting system. This helps technicians detect any minute imperfections. These imperfections are then filed down by hand. Here, a robot fully immerses and rotates the chassis in a galvanizing solution that prevents corrosion. Once the body has been primed, it passes through a device that dusts off the entire body with ostrich feather brushes. Next stop, the paint room, where robots spray the car body with a smooth, even coat of paint. Once the paint dries and cures, the robots apply several coats of varnish. The final step in body prep is a meticulous waxing by hand to remove any remaining blemishes. Moving on to the chassis, a technician uses a hoist to position and fasten the engine and gearbox in place. Here, robots transport the completed powertrain to the assembly area, where an automatic crane gently lowers the car body onto the chassis, which includes the fully assembled suspension, gearbox, and engine. This step is known as the marriage. Next, a worker installs the wheels with some help from a hydraulic lifting system. At the next station, technicians test all the dashboard components. This vehicle features a combination of analog and digital displays. A master computer runs the electronics and information systems. Again, with the help of a crane, technicians install the finished dashboard. The next step is the steering wheel. Assisted by a special assembly jig, a technician positions and tightens it onto the steering column. Workers lower the trunk cover and convertible hardtop into position, which is particular to this model of car. A worker double-checks the installation of the hydraulic mechanism. This beautiful road machine is the culmination of years of racing history, modern engineering, and dedicated craftsmanship. Now, watch this. This is one of the few cars that features a fully automated convertible hardtop. This beauty is now ready for the sun, wind, and the open road.